Welcome to approximating tangent lines. So the idea here is when we find a tangent line, we know the slope is the derivative, but sometimes that derivative is not so easy to find. So we know the slope of the tangent line is the derivative. But the derivative can be hard to find. And so sometimes what we do is we approximate the derivative. And so instead of taking a limit, we just use some specified h. So we approximate the derivative with just our f of x plus h minus f of x, or f of c plus h, sorry. F of c plus h minus f of c all over h for some h. So for example, let's go ahead and approximate the tangent line to the graph of f of x equals 2 to the x squared plus 1 at x equals 2 by using h equals 0.1. So again, we need a point and a slope. So the point, we are looking at the point 2, f of 2, or 2 to the 2 squared plus 1, that's a lot of 2's, or 2 to the 5th, better known as the point 2, 32. So that's our point. Then for the slope, technically or officially, it's f prime of 2, which would be the limit as h goes to 0 of f of 2 plus h minus f of 2 all over h, which in this case would be the limit as h goes to 0 of 2 to the 2 plus h quantity squared plus 1 all in the exponent, and then minus that 32 we found before all over h. This is not a pleasant limit. We could probably find it, but it would be a lot of work. Right? We'd have to use some exponent rules, manipulate things. So this is not the easy limit to find. So this would take some work. And so what we are going to do is we are going to approximate f prime of 2 by setting h equal to 0.1. So we have f prime of 2 is approximately 2 to the 2.1 squared plus 1 minus 32 all over 0.1. So if we do some simplification, this becomes 2 to the 5.41 minus 32 over 0.1, which is approximately 42.52 minus 32 over 0.1, which winds up simplifying to 105.2. We would have 10.52 divided by 0.1. Yeah. So that's going to be our slope. So or approximate. So the tangent approximation we have our y minus the y value of 32 is equal to our slope of 105.2 times x minus our x value, which was 2. And then, of course, we could rearrange that into slope intercept form if we wished, or we can leave it as is. So, but that is our tangent line approximation. What we are doing is we are approximating the slope, we are approximating the derivative.